Okay, so today we're going to be on lesson 2.5. We're going to start on page 115. So we're on page 115. So we're going to graph proportional relationships today. So our learning target is I can use a graph to determine whether two quantities are proportional. So on page 115, we've got this graph that shows the time it takes JC to print t-shirts for her school math club. So you can see that here is our graph. Our x-axis is our horizontal number line. Our y-axis is our vertical number line. What is this a snapshot of? What quadrant? Quadrant 1. So we're mainly going to be working in quadrant 1, where we have those positive x, positive y patterns. The number of t-shirts is our x-axis, so our number of teachers is going to be our independent variable. Our y-axis is going to be the time, so that's our dependent variable. So use the points in the graph to complete the tables. Are the quantities proportional? So this point, what does this point represent? Okay, 1, 5. So one t-shirt in 5 minutes. Okay, so one t-shirt in 5 minutes. What's our next ordered pair? 2 and 10. So 2x when x is 2, y is 10. So what does that mean? Okay, wait a minute, that's not what I was asking, not yet. What does that point 2, 10 mean? You should have a piece of paper out and like actively learning right now. Right? How many shirts, the number of minutes. So 2 t-shirts are done in 10 minutes. What's our next ordered pair?
3 t-shirts in 15 minutes.
Go ahead, honey. What'd you say, Brady?
3 t-shirts in
3
15 minutes.
t-shirts in 15 minutes. And what's our last ordered pair?
4 t-shirts in 20 minutes.
4 t-shirts, 20 minutes. Okay? So, moving from our first point, which is 1, 5, as you move from one point to the next of the graph, how does the x-coordinate change? And how does the y-coordinate change? Okay, so when I move from here to here, what's happening every time? What's that? We're going up. Okay, so as our number of t-shirts increase by 1, the number of minutes increases by 5. Okay, so our x-coordinate changes by 1, and our y-coordinate changes by 5. If I wanted to check for proportionality, what would I do? How would I check for proportionality, Craig?
We put x, y over x.
Very good. So don't forget our constant of proportionality okay, this is how we check for proportionality. K is equal to y over x every time.
Excuse me, interruption. I need the following students to meet outside of the office in the hallway for testing. Kennedy F. Accarello, Ava Alicia, Alexis Askew, Lucas Dylan Harris, Ray Durani, Haley Coleman, Cooper Graham,
You're going to need
Hayden
your stuff.
Graham,
Okay. So
Brendan
you can use the
Hagerman.
pencil.
Ethan Holman, Elliot Jankowski, Rosa Langford, Derek Lindbrick, Katie Lindbrick, Andrew Nicolay, Tucker Webb, Emma Wilson, and Brooke Yeager. Thank you.
Okay, you guys want to take your stuff, but you can only use a pencil. Okay? And don't write in the test booklets, only on the testing document. Okay? What? Yes, that's an IAT. Okay, so like Craig said, we're testing for proportionality, so we're testing y over x. Okay, so when we test for y over x, okay, our first is 5 over 1. Is that in simplest form? For our relationship to be proportional, what has to happen? What has to happen for the rest of them? They all have to reduce to 5 over 1. So 10 over 2, 15 over 3, and 20 over 4. Okay, 5 over 1 is already in simplest form. It's already our unit rate. What about 10 over 2? Zach? Okay, so divide by 2, divide by 2. 2 divided by 2 is 1. 10 divided by 2, are we proportional? Okay. What about the next one? What do 15 and 3 have in common? 3. 3 divided by 3? 15 divided by 3? Are we proportional? Okay. 20 divided by 4, so 4 divided by 4 is 1. 20 divided by 4, are we proportional? We're proportional because all of these are equal to one another. Okay, so what's our constant of proportionality? 5 over 1. What we can just say it's 5, right? So our constant of proportionality is just 5. This is a proportional relationship. Okay, now we look at the table. We're testing the table. Can we write an equation for this? Okay, it's a proportional relationship. Can we write an equation?
Yeah.
What's our equation that we use?
Y equals AX.
Okay, our equation for proportionality is y equals kx. Do we have our k? Yeah, we have our k. It's 5 over 1. So y is equal to kx. We know that our k is equal to 5. So our equation is y equals 5x. Our table showed proportionality, yes? Does our equation show proportionality? Okay, now, the last thing that they ask you to do is write points for 0 t-shirts and for 5 t-shirts. And graph the points and draw a line that passes through all 6 points. So if we make 0 t-shirts, where's our point going to be on our graph? Bob? 0, 0. Okay? So our point is going to be right here. 0 t-shirts takes us 0 time, right? And we can test that in our equation. Y equals 5 times 0. So y equals 0. What about 5 t-shirts? It'd be 25. So then our ordered pair would come up here. The last thing they ask you to do is draw a line. What do you notice about that line? It's straight. Something else do you notice?
All the lines.
What Bob? Okay, all the points connect. Okay, yeah. Does it go through the origin?
Yes.
Does it go through the origin?
Doesn't go through it.
Okay, right here.
It starts at it.
It starts there, then it goes up, right? At a constant rate. So if this is a proportional relationship, what can we say about the graph of a proportional relationship? That it has to be straight and it has to go through the origin. Very good. So the graph of a proportional relationship must be a straight line and it must go through the origin. It has to be those two things. If it is not those two things, a relationship is non-proportional. Okay? So things that we know, constant proportionality, k equals yx. Equation of proportionality, y equals kx. And then for a graph to be proportional, it has to be a straight line and go through the origin. If it doesn't meet those two criteria, it's non-proportional. That's for your graph. So here's Tanya. Tanya's working on her elliptical. She's exercising for 30 minutes. She noted the calories burned at 3 times during her workout. How can Tanya use this information to find how many calories she burned after 15 minutes of exercise? So in our table here, in our graph, she took this times and put it into a graph, right? So at 10 minutes, she burned 95 calories. At 20 minutes, she burned 190 calories. And at 30 minutes, she burned 285 calories. So this graph is showing the relationship between time exercised and calories burned. So time exercised is your x, calories burned is your y. Is this a proportional relationship?
Yes.
How could you test if it's a proportional relationship? Yes?
If it goes through the origin and it's a straight line.
Okay, is it a straight line? Does it go through the origin? So is it proportional?
Yes.
How else could we test if it's proportional? Zach,
Showing up the numbers on like 95 and 190 is just 95 times 2.
okay, so could we do a ratio table? Okay, so let's look at a ratio table. These are x and y. X is time. Y is calories. Okay, so in 10 minutes, she burned 95 calories. 20 minutes, how much did she burn? 190 calories. And in 30 minutes, do you know how to test proportionality from a table? How do we test proportionality from a table? Y over x. So k is equal to y over x. What does this tell you? That's our constant of proportionality. So our ratios, 95 over 10, 190 over 20, and 285 over 30. These all have to be equal to the same unit rate, correct?
Yep.
Okay, so someone other than Craig. Ready? 95 over 10. How do I calculate the unit rate from 95 over 10? Danica, go. Very good. Divide by 10. Divide by 10 here. If I divide by 10 here, I need to. What should you have out right now? What should you be doing right now? Calculating. Let's go. What's our unit rate, Bob? 9 and 5/10. Yes, absolutely. All right, so 190 over 20. I need to get to a unit rate. Craig, Danica, and Bob have already answered. Let's go. And Zach's already answered. Let's go. Someone else? Connor, what do you want to do? Divide by 20. Okay, whatever I do on the bottom, I have to. Okay. What do I do? What do I get when I divide 190 by 20? Shane? Okay. Are we proportional? Okay. What about our last one? Brooke, go. Thank you. Are we proportional?
Yes.
How do you know? Oh. Raise your hands. How do you know? Base.
They're all the same unit, right?
Okay, so when we divide this here, 30 by 30, we get 1. 285 divided by 30, we get 9.5. What's the equation that models this situation? What's our equation that would model the amount of time, the relationship between the amount of time and the calories burned? Zach? What? Very good. Calories is equal to constant proportionality multiplied by time. What's our constant proportionality? 9.5. So our equation that models the situation is 9.5 times x. The question was, how many calories does she burn after 15 minutes of exercise? So how would I find that? What could I do? Danica? Very good. So I take my equation, y equals 9 and 5/10, and multiply by the number of minutes. Our number of minutes is 15. Okay, so how many calories does she burn after 15 minutes? Everyone? 142 and 5/10. Okay. Is that reasonable? Is that answer reasonable? Okay, so Mason just said yes. Mason, how do you know that answer is reasonable?
Because it's below 190, it's above 95.
Okay, so right here in the middle, 10 and 20, what's our value right in the middle between 10 and 20? 15 minutes. So 15 minutes, we know she burns 142 and a half calories. Is that reasonable? Yeah, absolutely it's reasonable. So it's a good way to check yourself. We also know that the graph is proportional because it is a straight line that goes through the origin. Okay? So we've taken all these things, we've looked at the graph, straight line to the origin. We've looked at the table. All ratios are equivalent. We've put it into an equation of y equals kx. So those three things make our relationship proportional. That's the three ways that we test for proportionality. What questions do you have? Any so far? No? Okay. All right, let's look at this one. Okay, this is your try it. Each quarter cup serving of cereal has 3 grams of protein. How can you use the graph at the right to determine whether the quantities are proportional and to find how many grams of protein are in 1 cup of cereal? So 1 cup serving of cereal has 3 grams of protein. How would I model that on my graph? How would I model that in my graph? Quarter cup of cereal has 3 grams of protein. Bob, go ahead.
You go to 1/4 and then go up to 3.
Excellent. 1/4, and then we go up to 3. Okay? What if I don't have any cereal? Then 0, 0, right? What about a 1/2 cup of cereal? Okay, so why do you think that? So hold on, let me draw a table. Hold on. All right, so our x value is cups, our y value is, right? So our x value is cups of cereal. And then our y value is grams of protein. So the number of protein, the amount of protein we get depends on how many cups we consume, correct? So our protein depends on our cups. So we know if we eat 0 cups of cereal, then we're going to get what? 0 grams of protein, correct? They told us 1/4 cup of cereal gives us 3 grams of protein. So my question was, how much protein will you get if you eat a 1/2 cup? 6. How do you know? Okay, so Zach said 2/4, which is half, would then give us 6. Okay, so then 3/4 would give us how much? 3/4 you think will give us 9? So then how much would 1 cup give us? What do you think? 12? Everyone agree? Straight line?
Yeah.
So the origin? Is our relationship proportional?
Yes.
Okay? So So, we think this is true, correct? How would we know? Okay, so we could test for proportionality, right? K equals so our first one is 3 over 1/4. How do I get from 1/4 to 1? Okay, so divide. How many of you got 12? So what does that tell us? Were we correct? Do you think the rest of them equal 12 over 1?
Yes.
So what's our constant proportionality? Okay, so our K is equal to 12. So what's our equation? So our equation is y equals 12x. Okay. So real quick before we go today, this ordered pair is 112, correct? That's our, what else? Constant proportionality, which is also our what is this? And the ordered pair then would be 1, 9.5, right? What about here? Same thing? So our unit rate is always this point right here. Whatever 1 is, that's always our unit rate as well. So you could actually look from a graph, look at where your graph is traveling through 1, and you would have your unit rate. You wouldn't even have to calculate it. Okay? So that's, yes, dear. One more time, honey. Okay, so how would we put 1.5 on this graph? We couldn't. We'd really have to blow it up. So what we can look at it tomorrow. Like Desmos, we can put them into the table and then we can look at it. So we'll do that first thing tomorrow. Okay, good question. All right, so we got through examples. So we got to do 1 and 2 tomorrow. So tonight for homework, I want you to do page 119. And I want you to do 9 through, I just want you to do 9 and 11. Okay, that's it, 9 and 11. What? Oh, okay. It's Alex B's probably, yeah? Yeah, Alex.